Hi YouTube. So back in February this year, there was a critical vulnerability for the sudo Linux command, which I created a public proof of concept for. A few weeks later, I gave a talk to my security club about the vulnerability and what is security access control, what is setuid, and how that works, and how I exploited the vulnerability using a time of check, time of use raise condition. So please enjoy the video. So, when you run something in Windows, right, as admin, you're going to get this kind of prompt, right? Do you see it on your screen, the UAC prompt for, do you want to allow Notepad to make changes to your device? Do you guys see that? Okay, cool. Um, so the reason you have this is because normally when you're running as like your normal user, all the programs and commands that you run are as an unprivileged user. So that means even if you're in the administrator group, right? Like I'm an admin, like my user account on my laptop is an admin user, right? But all of the programs and stuff that I run normally, it's not run as an admin. It's just run as a low privilege level because that limits the kind of damage you can do to fuck up your own computer if you make a mistake, right? Like let's say I accidentally press like Control A in my C drive because I'm careless and I press delete. Well, normally if I was an admin, that would just wipe out my file system, right? But as a low privilege user, that's probably just going to fail right away. It's going to be like, hey, you're not an admin, you can't delete all the files in the root file system, right? So to illustrate, if I open a command prompt, okay, that's really small font. Okay, yeah. So if I open a command prompt and I type who am I, right? It's going to tell me I am PC user. So this is not an admin. And on the other hand, I can actually whip out a escalated shell if I open process hacker. Run as, okay. This is what the escalation does under the hood essentially. And now you can see I'm NT authority or NT system, right? So that would be an example of escalation on Windows. So that's an example that most people would be familiar with. So like when you, for example, have a program that's like, hey, you need to run this program as admin or it's not going to work. That's because it's probably doing some operations that require administrator level privileges on your computer, right? Some examples of stuff that might need that is like updating software, right? Because if you go to your C program files, and you go to the security, who is this owned by, right? This is owned by trusted installer, right? So normally, if I'm a normal user, I can't just go in here and be like, hey, LMAO, make a new file or whatever. If I want to make a new folder, it's going to have to go through this escalation. You see, you need to provide administrator permission to delete this folder. And if I wasn't an admin on my laptop, I wouldn't be able to delete stuff in program files, right? Obviously, that makes sense because these program files, it's like a global thing, right? These programs are shared by everyone that's using this laptop, right? For me, it's a single user system, but if you imagine like you have a workstation that has maybe 3 users sharing it, you don't want to have one guy go in there and delete like Google Chrome or something, or even worse, you don't want someone to go in there and backdoor Google Chrome to log everyone's passwords, right? So that's an example of why certain files need to have different permissions. And obviously, this is very basic stuff they teach you in like your very first information security class. Now we're up to speed on basically how permissions on contemporary operating systems work, right? And for example, this is my desktop in my home directory. This is my personal desktop, so obviously I have permission to write stuff here. So does this make sense to everyone? Now I'm going to talk about, okay, and I guess just one more example to drive the point home. If I open a notepad, I cannot go and edit, say, like C Windows System 32 drivers. I can't edit my host file normally. If I try to save it, it's not going to work. But if I run Notepad as admin, then I can save my host file. Okay, so on Linux, I'm SSH into a Linux box right now. So this is a Ubuntu box. That's a pretty typical Linux. So the way Ubuntu does permissions is very similar to Windows, actually. Or not, it's not totally similar, but conceptually, at the very high level, it's the same kind of idea I just showed you earlier. For example, if I drop to an unprivileged user, right? So now it says, who am I? I'm just like an unprivileged user, and I'm not an admin, okay? If I try to list the contents of the root user's home directory, those are obviously private because they belong to a different user, right? That's an example of one thing I can't do as a non-privileged user. root owns this folder, right? So this means that root can read this, but nobody else can. There's no permissions for everyone else. So that's something I cannot do as an unprivileged user. I cannot, like look at other people's passwords. I can't show the passwords file because the passwords are private, that's secure data. So you see that does not have read permissions for me, right? Whereas if I make, let's say, a file for myself, it does have read permissions for me. And also it's owned by me, right? So this passwords file called the shadow file, this is owned by root, and it's not owned by me, so obviously I cannot read it. And if I make like a file for myself, I do have permissions and I can't read it. Does that make sense? So this is how permissions translate to Linux. Another example is we have some critical system utilities, right? Like maybe ls, right? Because ls is just a program on this computer, right? ls is the command that lists the files in a directory, right? So if I find out where the bin ls is, okay, so the program is running off of this file. Whoops. It would be pretty bad if, as an unprivileged user, I could just, but backdoor this ls, right? So obviously, if I try to modify this file, it's going to be like permission denied, right? Or likewise, there's also a file on Linux, ls-l etc password. This is the file that stores the user data. So this is like all the entries of who is a user, what is their user ID, and what permissions do they have. So this file is very system critical, right? So as a normal user, if I try to edit this file, and let's say I just try to add a new user, it's going to say it's unwritable and it's permission denied. So I think I've driven the point home. I know you guys aren't stupid. These are just examples of how permissions work. And you remember from earlier when I tried to run Notepad as admin, it's going to give me, do you want to do the thing or whatever? And since I'm an admin user, it's not going to ask me for my password on my laptop. But if I was not an admin user, it's going to ask me for my password. And similarly, on Linux, if I try to do some operations as admin, the way that's done on Linux is use sudo, which stands for super user do. Okay, you do the thing as the super user. But okay, here it's not even giving me the password prompt because I'm not even an administrative user, so it's going to reject me right away. It's not going to let me do the thing. On other systems, if I try to become, it's going to ask me for my password, right? So that's an example of what sudo does. Essentially, it's logging in as, it's like temporarily switching to administrative mode. It's basically running something as admin. Does that make sense? So that's what sudo does. That's why sudo is so important, because it's essentially a gateway to become the administrative user to perform some kind of task. It's basically letting you run something as admin, right? So if you found some kind of flaw in sudo, that would let you do whatever you want as admin, right? With no kind of proper access control. That would totally bypass all the permissions and access control in the system, right? How do you think sudo works? Because if I am an admin user, right? And I guess I'm just going to add myself to sudoers real fast. I think it's usermod-ag fuck. Okay, yeah, usermod ag wheels meme. Okay, okay, yeah, so now I should have the sudo privilege. Okay, or maybe not. Maybe I'm just stupid. Oh, that's right. I need to relog. Okay, there we go. Now I'm an administrative user because I have the sudo privilege. I'm in the sudo group, which is like the admin group. And what I did earlier is I did usermod-ag sudo meme, which is I will modify my user meme to add myself to the group sudo. If you're wondering how I memorize all these commands, it's because I have no life. So now that I'm a sudo user or administrative user on Linux, now if I try to do sudo, it's going to ask me, okay, it's going to let me do the thing, right? I can do sudo ls, I can do sudo who am I, and oh, you see now when I run who am I as root, I am root, or sudo id, stuff like that, right? So that's how sudo works. It basically temporarily switches your user to root to run a command. So when you do sudo, it's essentially my user ID normally is 1001, which is like not a privileged user, right? But if I do sudo ID, it's going to temporarily switch me to root and then run the command that I give it. So if I do sudo ls slash etc password or etc shadow or maybe sudo cat etc shadow, it's going to actually let me read that file. Whereas if I do that normally, I'm going to not have the privilege to do it. Because shadow is owned by root. And since I'm temporarily switching to root, that means I have the privilege to read that file because it's owned by root, right? So you can think of sudo as basically like running as admin. And if I do sudo su, that's like running a command prompt as admin. You get a whole shell as root. Now I have a question for the chat. How do you guys think sudo actually works? Because to become an admin, like how do you escalate privileges, right? It seems pretty simple to drop privileges, right? It seems pretty simple if you're a root user, you just log in as like a low privilege user. But how come as a low privilege user are able to mysteriously become an admin if you think about it? That seems kind of strange, isn't it? Because if any unprivileged user can become an admin, that's obviously no good. So then how does this system know who can become admin, and also when are these checks performed, right? Because if you think about it, for example, the configuration for who is an admin is partially in etc sudoers. But a low privileged user can't even read that file, right? The database for who has admin privileges is stored in a privileged file. So to switch to an admin mode, you obviously have to check whether you're an admin, right? In the sudoers file. But how can a low privileged user make that check before they switch to the admin mode? So there seems to be some kind of chicken egg problem. To illustrate, I will use MS Paint, my favorite program. The chicken egg problem here is sudo is owned by root, so we can't read it. But we need to read it before we become admin, so we can check if we're authorized or not. So there's this loop here basically, right? It's because this problem causes this problem. So there needs to be some kind of way to break this kind of dependency chain, right? Because the first problem is it's not owned by us, so we can't read it. But the second problem is we need to read it to become admin. So the way this is done, the way that Linux breaks this loop is that it has the concept of SUID or set UID bit, okay? The way that SUID works is, I'll show you how sudo works. So sudo is just another command on the computer, right? So which sudo, it's just running off this file on the file system. Oh wow, it's red. Red means scary. So the way this works is, if you'll notice, sudo. If you notice, there's this S bit in the permissions field, whereas all the other files don't have that. So this S bit is very special, okay? This S stands for set UID, okay? Sudo is very important, okay? That's why it gets the SUID field, or the SUID bit. SUID is essentially how they break this loop that I was talking about earlier, right? The way that SUID works is that when you run sudo, actually, it doesn't perform any checks at all. It just directly elevates you to UID 0, which is root. The way SUID works is that any program that's marked SUID, this SUID bit right here, any program that's marked SUID will immediately switch to the user ID of whoever owns that file, right? So when I run sudo, because this sudo file on the hard drive is owned by root, the system is going to immediately switch me to UID 0 equals root without any checks at all yet. So that's very dangerous, right? Does that make sense to everyone? Now I'm an unprivileged user. I'm daemon UID 2, which is not privileged, okay? And if I run sudo su, so now sudo is running, okay? And if I do a process list for all the processes on this system and I grep for the sudo process, you can see that sudo is actually running as root already before it even authenticated me. I haven't even put in the password yet, right? But this process is already running as root, even though I started it as a low privilege user and I didn't even authenticate anything yet. Does that make sense? So, and I'm gonna like fail the password prompt, and it's gonna be give me 3 tries and waste my time. And it just drops and doesn't let me authenticate. So it's technically okay to switch it to root immediately, because the idea is that we trust this sudo program to be, correct and not vulnerable and not hackable and not bypassable, okay? We're basically trusting this sudo program to not have any, any backdoors in it or any like, bypasses in it that let us get past the authentication. We're basically trusting this pseudo binary to be a gatekeeper of the system. Does that make sense? So essentially we have this world which is like unprivileged. Okay, so this is unpriv, and then we have this privileged world which is like root. Okay, and then there's gonna be like a big like gate. Okay, a big gate, and maybe the gate has like some spires on it. It's like a gate. Okay, and then there's like a security guard. This security guard is like Mr. Sudo. Okay, that's the deal. So I am meme, and my user is 1001, and this is root. Okay, does this make sense? And to get through this gate, we have to pass through the sudo program. Okay, and we trust sudo to do his job. Okay, we hope that we cannot just walk around him. Hopefully we have to go through Mr. Sudo to become root when we're doing the set UID. Oh, and Mr. Sudo he has the set UID. Okay, he has the set UID. So we're basically trusting sudo to not fuck up and let us just walk around him. So if we could do some kind of if we could do something like this and just maybe go around him, that'd be very bad. Because then that would let us escalate privileges on the system for free, right? So we're basically trusting sudo to not fuck up. And setuid is used on Linux basically whenever you need to let an unprivileged user do something that is normally privileged, but in a way that you think is safe and contained, essentially like it can't possibly go tits up. If it goes tits up, then that would be very bad. Another example of a setuid binary, and this might be surprising to you, is do you guys know what ping is? Have you guys know what ping is, right? Like you ping IP address, you ping a website to see if it's up, right? So so obviously any user can just ping something, right? It's just ping. Like what can you do with that? Okay, so on a lot of systems, ping is actually a SUID binary because to use ping, you have to use these things called raw sockets, which are normally not available to low privilege users. But ping is just ping, so we trust ping to not like fuck up and let the user do something super violent and aggressive and something that can be used to exploit the system, right? So that's why bin ping is SUID. We basically trust ping to not fuck up and not let the user exploit the system using it. Now an example of an SUID fuck up, Nano is just a text editor. Okay, I can open files, I can save files, I can write files. A big fuck up is if I take, let's say, where is Nano? If I take Nano and I just make a copy of it, I don't know, let's just put it, I'll just call it an LOL, okay? So now I have this copy of Nano and this LOL in root. So it's just Nano, it's just a text editor, there's no fuck up yet. A big fuck up is if I add the SUID bit to LOL, okay? And it's owned by root. So imagine if I am a low privilege user, like, okay, I'm Damon, and now guess what? Now I can just do LOL. Okay, now we have a text editor that's running as root, and I can do whatever the fuck I want. So now there's just a text editor running as root with root privileges. So for example, I can just open etc password. Okay, and you notice it didn't say not writable. Now I can just add a user here. Let's just say I'm going to change my user ID to 0 and become root. That is free real estate. Okay, so that was a big fuck up because, Nano is something that lets users do a whole lot of shit, and one of those shits is escalate privilege on the system, so that's very bad. So now if I do this, okay, it's giving me a hard time. Now I'm root, even though I'm running as Damon. So that's like pretty not great. I'm going to undo that. I'm going to undo that change, but that's an example of an SUID fuck up. Okay? So you can see how SUID binaries need to be very trustworthy and not fuck up. Okay, so did you guys see how that works, right? So what happened earlier is now we have maybe like like when we made Nano, that was a big fuck up. It's like there's a big hole in the gate. Got him. So that's why we cannot make SUID binaries that are vulnerable. But if there is a vulnerability in SUID program, to me, as an attacker, my shirt even says hacker1 on it. As me, as an attacker, I'm like, that's free real estate. That's free real estate. I can just do the SUID fuck up and we can become root, even though we shouldn't be. Okay? Okay, and I should probably remove myself from that group. Is it in etc groups? Yeah, okay. Easy clap. Okay. Okay, so I'm no longer an administrative user. So I'm going to show you what tonight's lecture is actually about. So all of that up to now was this setup for what is SUID, what is privileges, and all that shit. Now we're going to get to the really juicy part, okay? Oh, and by the way, the SUID fuck-up I told you about, okay, so if you're like an attacker, right, and you do, for example, you audit systems, and you do pen testing, where you do penetration testing, when you land a shell in a box, when you get your first little shitty shell in the box and you're like some dipshit low privilege user like maybe www.data or Apache or some shit like that, you're like, wow, it would be really great. It'd be really great if I could become root on this box. One thing you can do is you can just look on the system for like a big SUID fuck up. But then you can run a command to basically find all the SUID binaries, and then you can go through each of them and be like, oh wow, this one should not be SUID. I can use this to escalate privileges on the system. And a lot of times, for some reason, people just like fuck it up, and there's this SUID binaries chilling around that really shouldn't be SUID, and then you can use that to escalate privileges. This shit happens all the time. This happens all the time. And another thing that happens is, okay, let's say you're doing like a pen test and you land a shell in the box, and one thing that's really funny is when you notice like somebody else has put a bad binary there for whatever reason, as like a backdoor. For example, if I wanted to make a backdoor, this is how I would make a backdoor. I would just, I would just go to cd bin, and I will just take maybe like sh or ash or sh. I can just do chmod plus x bash, and then every shell in the system is now SUID. That's one way you can make like a backdoor. A really funny thing is when you get a shell in a system and you realize somebody else has already like been there before, like some other attacker has already hacked this system, and you just find their backdoor chilling around. You just find their SUID backdoor just chilling there. That's really funny. So we trust Mr. Sudo here to not fuck up and not make the system insecure, right? So we obviously we need to make it so even if we are very rude to Mr. Sudo should not be vulnerable to the attack. Okay, Mr. Sudo needs to be very good at defending himself. You cannot have you cannot have shit like buffer overflow or some shit like that, or command injection. That is very bad. We cannot have that, okay? So Mr. Sudo, we expect him to have the very high reliability, okay? We do not want him to crash. We do not want him to buffer overflow. We don't want him to segfault, okay? But recently, about 2 weeks ago, there was a new disclosure from Qualys about the fact that Sudo does have a big vulnerability in it. We can crash Sudo. We can even buffer overflow the Sudo. And I'll show you that right now. Watch this. It's as simple as this. Okay, so I'm an unprivileged user, okay? Now watch this. This is the trick. I'm going to run Sudo with some fancy arguments, okay? This is not so bad. Now watch happens if I do this and add a bunch of A's. Okay, shit is about to get really spicy with a bunch of fucking A's. Okay. Oh, that's right. It needs to be sudo edit. Okay? Sudo edit is like sudo's cousin. You can think of it like that. Okay? Sudo edit actually is just a link to sudo, but as a different name. So anyways, we can run sudo edit with a big A. And, oh no, we got the double free or corruption. So we just did the memory corruption on the sudo. That is very bad. Also, I can show you the big A at the end, and it will have a different crash, I think. Hey, okay. Yeah, and depending on how many A's we give it, it will exhibit different types of crashes. So, oh, this is very interesting. Very interesting. I thought Mr. Sudo was not supposed to mess up like this. Okay, so depending on how many A's we give it, that's very interesting. That's very interesting. And maybe I put the A's here. Okay, well, let's assume, I'm very curious. I wonder what will happen if I make the big A's. Okay? If you read the advisory, essentially what's happening is the code for parsing the command line arguments to sudo, which are specified from an untrusted, unprivileged user, right? The code for parsing the parameters essentially has a bug in it. They have an off by one error that leads to a buffer overflow. So what that means is the program is only allocating this much space on, like in memory, for the arguments, okay? But then you can smash it and go way past the end of the buffer and just overwrite whatever shit is next to it in memory with whatever you want. So that is very cool. If there is, let's say, a data structure containing whether you're authorized or not, you can smash that with like, oh yes, I am authorized. If there's a function pointer, you could smash that with a function pointer that gives you a shell. And if there is, like a file name there, maybe you can smash that file name to point to some file that you control and do some very like interesting memes with that. Does that make sense to everyone? Why buffer overflow and memory corruption is very dangerous? When you have memory corruption, it basically means that the program has no more guarantees anymore because you can basically just manipulate the memory in whatever way is convenient for the attacker to do whatever you need to do. Does that make sense? Okay. So how the attack works is essentially like this. Smash that like button. Yeah, don't forget to like and subscribe. Ring the bell. All notifications on. So how this vulnerability works is that this trailing semicolon is what causes the bug. So we always need that to be there. The number of A's before the semicolon, or just in the arguments in total, controls the size of the buffer that we are going to overflow. So if I allocate like this, it's going to make enough space for the dash S and the A's and the backslash. Okay, so it's going to allocate like a buffer of size 1, 2, 3, 4, 6. It's going to allocate a buffer of size 7, which gets rounded up to 16s. But yeah, that's just all details. It's going to allocate a buffer of whatever size based on how big the arguments are. And all the shit in the environment that comes before the sudo right now, that is all the stuff that will get overflown past into the buffer. So this is the size of our arguments, and this is the size of the environment variables that we can use to overflow that buffer. So this is all the shit that we're smashing. A lot of times you just give a big number of A's and the program crashes. Well, that used to be more of the case like maybe 10, 15 years ago. And then like people really started getting their act together, but this shit still happens from time to time. And in critical programs like Sudo too. So that's just it's very funny. It's very cool. So the reason I wanted to show this exploit, another reason why, is because it's shameless self-promotion. I actually wrote one of the proof of concepts for this vulnerability as soon as it came out, which is very fun because nobody has patched it yet. Basically, like very few people have patched this because it came out 2 weeks ago and nobody updates their system still. So that's pretty funny. So a lot of boxes are still vulnerable to this. I'll show you the exploit for it. So one of the ways that you can exploit this is essentially you overwrite a file name, and because you overwrite that file name, it's going to that file name is a file name for a file that sudo creates every time you run sudo. And normally it's supposed to go to some place that is like just, some standard expected location. But if you overwrite that file name with something bad, then you can just make sudo create whatever files as root, which is very interesting. Okay, so I'll show you that. I just have to compile my exploit. Okay, yeah. So if I run my exploit, okay, yeah. I just have to do this. I'm going to back up my password file because I'm going to mess it up using the exploit. So what I'm going to do is I'll run the exploit for you just to show the very obvious effect. Okay. Now I got sudo. I did the memory corruption. I smashed a file name that was chilling in sudo's memory, and I replaced it with a lamau, big chungus, and then a bunch of garbage. Okay. So if you'll notice, all these directories are actually created as root. which is, can I stop this? Okay, yeah. So all these directories are, okay, not all of them are created as root, but some of them are created as root, which is very, very interesting because I should not be able to create files and directories as root, right? As an unprivileged user, obviously, right? Because if I can create stuff as root, then I could probably, overwrite some very important file. Does that make sense? Or in the very least, I can make some files that you can't delete because like they're owned by root. So obviously, sudo should not be making directories called alamau big chungus, right? What actually goes on is that it's going to write a file. Okay, it's going to write a file called with the name of the current user, and it's going to write some shit to that file. What it writes to it is not really important. All you have to know is that it's controllable by us. Okay, we can control what gets written to that file using our memory corruption. So it's going to write to a file called alamau big chungus, and inside that directory, it's going to make a file called meme because my current user is meme, and it's going to write some shit that we control into that file. That's pretty cool and all, but how can I use this to like really do some bad shit? What we're going to do is we're going to basically make a link to the password file on the system. That's the file that has the list of all the users and their details, right? And their user IDs. So what we're going to do is we're going to just make a link to the password file, and we're going to try to hopefully get sudo, we're going to trick sudo into writing the shit that we control into this passwords file, and we can just put whatever we want in there. And then that will let us essentially make new users or give ourselves user ID equals 0. So that's the game plan. We're going to trick sudo into writing some shit that we control to make ourselves admin by writing into this very important file. And we use the symlink because it always writes this file name, and it does not like it if we try to write to etc password directly. That's just one of the things for the attack that has to work. Also, it's like a race condition. It's like a time-based thing. So like we're trying to do the thing right as sudo does it to basically pull out the rug under from sudo as it's doing its thing. Basically, sudo doesn't like to write to stuff that is not owned by root, okay? Because that's like, oh, it's not safe. It's not safe. So what we're going to do is we're going to be like, it's going to first do the check. This is called a time of check, time of use vulnerability, by the way. So TalkTow stands for time of check versus time of use. So sudo tries its very, very best to not fuck it up because it tries to be very secure. It tries very best, but it does have a mistake in it. This is another mistake that, apart from the memory corruption, this is a second mistake that we're going to leverage in sudo. First, sudo is going to check if the file, the timestamp file is the one we're overwriting. The file is owned by root, and it's like, if not root, like fail. But if root, write the shit. So this is in theory, this is secure, right? Because as an unprivileged user, I cannot make this link. I cannot make this link to the password file, the very important file. I cannot make the link because this link is owned by me, and it does not like that. Okay? It's like, okay, so if we are just doing this normally, okay, so first our attacker is gonna, make the bad link, make the bad link. Okay? Oh, a link, by the way, is just like it's like a shortcut. Whenever you reference that file, it references the destination file. So if I ls, if I just cat that, okay, it's wasting my time. If I cat that, it's going to give me the whatever is in the destination file. It's basically like a shortcut. So we're going to make the bad link, and then sudo will be like, this file is not owned by root, so we're just going to fail and not do the right. Okay, so then we cannot exploit it. But what if we do something like this? What if we just do it right as sudo is making that check? So what if we do this? What if we do this? We're going to let sudo check the thing first. It's like, It's like, It's like, doesn't exist. Okay? Okay? And then before it can write the shit, now we make the bad link. Now we make the bad link. Right? the shit to the bad link to the. And actually, TalkTow is very important. Is a very important concept in security. TalkTow happens in all kinds of applications, not just Sudo, not even just C programs, not even Linux programs. It happens all over the place. It happens in the Linux kernel, happens Windows kernel, it happens in web applications, right? Basically, anytime that you have this anti-pattern, the attacker can just slip in here after the check happens to make sure the bad thing's not going on, and just do the bad thing after the check, but before the use. So that's why it's very important that the solution to TalkTow is you have to do this all atomically, meaning you do the check and the write at the same atomic operation, so there's no way for the attacker to jam in there and do the thing. But normally that's very tricky and it's very hard to do. So that's why you see TalkTow happen all over the place, because doing shit atomically is just like a lot of fucking work. Like, why do it properly if I can just, make the TalkTow vulnerability? Like, okay, I'm not paid to make this shit secure. Like, come on. Right? So TalkTow is something that happens all over the place, and we're going to be using this TalkTow mistake, this TalkTow bug in Sudo to also to do our bad attack. So our first mistake was heap buffer overflow. And the second mistake is TalkTow. Granted, this second TalkTow is not normally a big deal if there wasn't for the heap overflow, but it's still a weakness that we can leverage either way, right? So that's why we have to try like a bajillion times. Each of these folders is the exploit running sudo one time. The reason we have to try a bajillion times is because we have no idea when it's going to do the check. So we're just basically going to run sudo and just wait a little bit and hope that we get the timing right. Does that make sense? So in the exploit code, you can actually see that. I wait for 10 milliseconds or 10,000 microseconds. What I do is I run sudo in the background. Okay, I run sudo in the background, and I wait for 10 milliseconds, and I just hope that we got the timing right, and then we try to make the bad link. Does that make sense? Do you see how this is going on in the code? We're going to run sudo in the background with fork. We're going to fork the background. We're going to run sudo, and we're going to wait for 10 milliseconds because maybe it'll just work. Maybe that is just the right time. On some systems, it might be 20 milliseconds. On some systems, it might be 5 milliseconds. Depends on how fast the computer is. That's pretty funny. The exploit is not reliable. But anyways, we just hope that after 10 milliseconds, okay, maybe after 10 milliseconds, this is 10 milliseconds. Maybe 10 milliseconds later, it's past the check, but it didn't do the right yet. So we wait 10 milliseconds, and then we make the bad link. Okay, so does everyone see what's going on here now? Okay. Obviously, it's not reliable because, waiting for 10 milliseconds is kind of bullshit because, the system, somebody might have, run a process, and now there's more CPU loads, and the CPU is like, there's more work, so processes run a little bit slower because there's more processes running. So it's kind of not reliable. It's kind of luck-based. But if you just run it like a bajillion times, at least one of those times has to succeed, right? So that's the big idea. We're going to run it a bajillion times and try to get our race condition to succeed. This is called a race condition because you're racing two tasks, right? You have one exploit guy running this way, and then you have sudo running at the same time. So it's a race. It's to see, who can get there first. And race conditions are just so fun to exploit. As an exploit developer, I just love writing race condition exploits because I just love it when I have no idea whether my timing is wrong or my just exploit is wrong. It's so much fun to write race condition exploits. Okay, so first I need to clean up all this shit that the previous attempt left behind. But now I'm just going to run the exploit, and hopefully it'll work. Okay, let's do the thing. Let's see if it works. I hope it works. It should work. Target file has a bruh moment. Success. Okay? So, do you guys remember what etc password looks like before? This is what etc password looks like before. Okay? Now, let's look at what etc password looks like after. So, this is after our target file etc password had a bruh moment. There is some bullshit here. That's just, some random fucking memory from the process that we leaked. No way around that. And then there's the contents that we specified. So this is all the shit that we control. This is all the shit that we control. We told it to write some bad shit in here. And look at this. Look at this. I am meme. Normally, what was the old password like? The old password was meme with user ID 1001, which is not root. But now our password is a bunch of shit, the normal password, and then the meme, which is my user, with user ID 0. Okay, user ID 0. So now we're root, right? And then some shit at the end too. So if I run bash again and I do meme with ID 0, poggers. And I can even edit a privileged file. And now I'm going to unfuck up my system because that is not cool. So yeah, that is how the exploit works. I just walked you through a real-world exploit that is, still possible on a lot of systems. Like I would say probably at least 50% of systems do not have this patched. So yeah, not saying don't use this knowledge ethically. I'm not responsible for whatever stupid shit you get yourself into. But yeah, that's pretty poggers. Okay, you can escalate from an unprivileged user to a privileged user using this exploit. On Ubuntu 18.04, 20.04, there's proof of concepts for this exploit on GitHub. You just literally download the exploit, you compile it, and you run it, and just get root. It's very cool. It's very poggers. PogChamp. Okay, answering questions. So is the goal to have the bad link made at the exact time it takes to check the sudo? Yes, exactly. Right? Because sudo is going to make sure the bad link does not exist. But if we make the thing right after it does the check, but before it actually uses that file name, then that's Gucci. Does it make sense? So we're basically racing it to make sure that happens at the exact right time. Because think about what happens if it happens too early. Let's say we make the bad link too early. Then it's going to be like, oh, well, it exists, and it's not owned by root, so we're going to fail. So that's what happens if we make it too early. So if we make it too early, it's going to not satisfy this check, and it's going to get angry, it's going to fail. Okay? And then let's say we make the bad link too late. If we make the bad link too late, it's going to write the shit before it even uses our link, because it's not even there. We didn't even make it yet. So that's what happens if we make our bad link too late. And if we make it just right, then it will bypass the check, but also be used by the right. How to heap overflow. Okay, let me tell you about exploiting this fucking bug. This is so piece of shit. I did this for 3 days. I worked on this bug for like 10 hours a day for 3 fucking days. I skipped all my lecture and all my fucking homework too. So, heap overflows are insanely, tricky to exploit. They're very, very hard to exploit. What I did was, remember how earlier I was just like making random number of A's? So first of all, I wrote a program to automate trying out different numbers of A's. It's like, oh, if I make 100 A's here and 50 A's here and 30 A's there, what will happen? Okay, what if I use B's instead of A's? Okay, so I made a fuzzer to basically automate that, and I would take the crash dumps from Sudo called core files, and it would load them into a debugger, GDB, and it would parse those core files to see where it crashed and what the backtrace was. And then I went through all those crash logs and see which crashes are interesting. Oh, this crashes in a very, very interesting location. It's a very interesting place for it to crash. Very, very interesting spot for it to crash because I overrode some very juicer data, right? So I basically went through all those, and it didn't fucking work. I didn't find any interesting crash logs. Then on the 4th day, I was just trying random shit out, and I did find this one. And I was like, oh, PogChamp, I can use this, and then we use that, and that's the Pog. So basically, I just tried random shit until it worked. This happens all the time, actually. It's called fuzzing. It's actually a big field of research in security right now. You just try random shit and see if it crashes in a bad way, or see if it crashes in general. Yeah, that is called fuzzing. Because you just try random shit. Just try random shit. So in summary, we basically went to Mr. Sudo and we just kicked the shit out of him. We just kicked the shit out of him, and then we got the root privilege. That's basically what happened. Okay, so that's the end of the lecture. Yeah, thanks for coming.